Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 9, part A, from the specimen paper of the Pure Mathematics 3, paper 3 of the 9709 Cambridge International A-level exam. So 9A is about differentiation, 9B is about integration. I'm going to take them as two separate videos, so I can classify them according to topic as well. So for the first question of 9 part A, it says the diagram shows a curve y equals sine squared 2x times cosine x for x values between 0 up to half pi inclusive and the maximum point M. So we got to find the x coordinates of the point M. Now M is, as they say, the maximum point. It's a turning point. Okay, and what we should know from our understanding of calculus basically is that the gradient at the maximum and the minimum is going to be 0. So we can say at M the gradient has to be equal to 0. The gradient is equal to 0 at that point. Okay, so that means if we find dy dx, we have to equate it to 0 because dy dx is 0 at this point, and then we can find the value of x at that point. Okay, so we got to find, in order for us to answer the question, we got to find what dy dx is. So we have y equals sine squared of 2x times cosine x, and we want to find dy dx. Now, to differentiate something like this, where we have a product of two completely separate functions, you don't have a function inside another function, you can't use a chain rule here for the whole thing. We have to take each product as a separate thing. So I'm going to take the first product u, I'm going to take that sine squared 2x, which actually is the same thing as saying the sine of 2x all squared. I'm going to write it like this because it just makes it easier for us to deal with. So I'll just make a bit of space. Okay, so that's u, and v is going to be cosine x. Alright, so what we need to do to use the product rule, which is in your formula sheets, actually it's in your formula sheet, so I'll just bring it up for you. Okay, so here we have what's in your formula sheet for differentiation, and you can see here what we're interested in here is this uv thing, uv. Okay, so uv, so the differential of u times v, where u and v are both functions in terms of x, is equal to v times du dx plus u times dv dx. Okay, so we need to find du dx, and we need to find dv dx. Alright, so let's start with dv dx first. dv dx is the easy one. In Cambridge, for sine and cosine x, the differentials are given. So we know that if your function is cosine x, the differential of that is minus sine x. This is f of x is f dash of x. So we're going to use this. This becomes minus sine x. That's pretty simple. For here, we have to use a bit more working because we have something which is a function inside a function. We have to use the chain rule. So the main function here is something raised to the power of 2, for which we use this power kind of rule. So we multiply by the power. So you have 2 times. Then you have the sine of 2x to the power of 1. But then by the chain rule, we multiply by the differential of what's inside the function. So we have to multiply by the differential of sine 2x. If you differentiate sine 2x, you're going to get 2 times cosine 2x, because you're going to use the chain rule again. Because differential of sine 2x gives you cosine 2x, and the differential of 2x gives you 2. So we're left with basically 2 times sine 2x times cosine 2x times 2. That's like what's happened there. So let's write this out in its simplified form. So du dx is going to be 4 times sine 2x times cosine of 2x. And dv dx is minus sine x. So I'll just put that a bit lower. Alright, so we have now differentiated what we need to differentiate. So this formula sheet, I'm going to get rid of it now. So the formula sheet has everything that you need to be able to differentiate these type of trig functions, and even has the product and the quotient rules there for you. So let me just show you how we can use this. I mean, this you could do without looking at the sheet after a little while. It's pretty simple. But we got to do v times du dx, which is this times this, plus u times dv dx, which is this times that. So we're going to have cosine x times all of this. So you end up with dy dx equals 2. You're going to have 4 times sine 2x times cosine 2x times cosine of x, plus, and we're going to have u times dv dx, which is sine squared of 2x times minus sine x. Okay, so we have here what dy dx is equal to. Let me just get rid of this now, as I said. So this is dy dx. This is dy dx. Okay, now to make things a bit neater, what I'll do is I'll just bring all of this down. Okay, so now, so let's just simplify this a little bit before we continue. So dy dx therefore is going to be, now for this, I'll leave it like this for now, 4 times the sine of 2x times the cosine of 2x times the cosine of x. This will be minus sine squared of 2x minus sine squared of 2x times sine x. Okay, so that's the differential of this expression here. Now we have to, as we said, we know that at the point M, dy dx equals 0. So you have to equate this to 0. So you have 4 times the sine of 2x times the cosine of 2x times the cosine of x minus the sine squared of 2x times the sine of x equals 0. Alright, so we have, to make this a bit simpler, what we can see there's a common factor of sine 2x in both of these terms. So I can take that out, sine of 2x, as a common factor, in which case I'll be left with 4 times the cosine of 2x times the cosine of x minus the sine of 2x times the sine of x equals 0. Okay, now what can we do next? Well, we can say either sine of 2x equals 0. Let's see if this leads to any solutions. That means 2x equals 0. That means x equals 0. So that's obviously not the point that we're looking for. That's going to be a minimum over there. Okay, and the other place where 2x equals 0, the sine of 2x equals 0 is when 2x is equal to pi. We know that the sine curve becomes 0 at pi again. So when x equals pi over 2, well, we know that these are both minimums. These are both minimums. We know that from the graph. So that gives us where dy dx is 0, but not the point that we want. So to find the point we want, we obviously have to solve this part of the equation. So now to solve this part of the equation, we'll say 4 times the cosine of 2x times the cosine of x minus the sine of 2x times the sine of x equals 0. So how do we solve something like this? Well, what we need to do is we need to try to rewrite them so that they're in terms of the same angle. Okay, so here we have double angles and here we have single angles, and it's easier to break the doubles into singles. So let's change cosine 2x and sine 2x into single angles. Now if I change this such that it becomes all cosines, then I have to use the identity for cosine of 2x. Okay, now again, with Cambridge, they give you all the formulae. So I'm going to bring those up now. Okay, so this is the formula sheet. Well, this is from the formula sheet for trigonometry for what you get in your exam. And we're going to try to see how we can rewrite this such that we can be able to answer the question properly. So I can see here, what I could do is, I know that cosine 2x can be expressed in terms of cosine squared x. And sine of 2x can also be expressed in terms of cosine squared x. Sine of 2x can be expressed in terms of sine x and cosine x. So this one we have no choice. This is going to become 2 sine x cosine x. We can use this identity here. the sine of 2a equals 2 sine a cosine. For this one we have no choice. So let's write this as 2 sine x times cosine x, and then we have another sine x there. That was from before. So this became that. Okay. For cosine 2x we have a choice. We can rewrite it as 2 cosine squared x minus 1 or 1 minus 2 sine squared x. Okay. I'm thinking to change it into 2 cosine squared x minus 1 such that we'll have just the same ratio on this for everything. So this will become then 2 will be 4 times. Let me write that on the outside. So you have 4 times. Then you have 2 cosine squared x minus 1. Okay, and that will be times cosine x. Okay, so that might help us there. Now this will give us, if we think about that, let's expand this. This will be like 4 times cosine x times 2 cosine squared x minus 1. And here we can write this as 2 because the sine x times sine x is 2 sine squared x times cosine x. In fact, I'll write it the other way around and you'll see why in a minute. Doesn't really matter, but 2 times cosine x times sine of squared x equals 0. Now, what I'm trying to do is write everything with the same ratio so it will be easy to solve. So what we've got left here is sine squared x, which you can write as 1 minus cosine squared x, as we know from our basic identity, which we should know, which is also given. Okay. Cosine squared theta plus sine squared theta equals 1. That means sine squared theta is 1 minus cosine squared theta. So we can rewrite this sine squared theta as that. So I'm going to expand this. This will be 8 times cosine cubed x minus 4 times cosine x, and this will be 2 minus 2 times the cosine of x times 1 minus the cosine squared of x. Sine squared x is 1 minus cosine squared of x. So now completing the expansion of the other bracket now. So 8 cosine cubed x minus 4 times cosine of x. Now if I expand this, I'll have minus 2 cosine of x, and minus 2 times minus, which is plus 2 cosine cubed x equals 0. So now we can see we got some like terms. We will get 10 times cosine cubed x minus 6 times cosine x equals 0. And we can see there's a common factor of cosine x. If we take that out, cosine x times 10 cosine squared x. In fact, we can take out a 2 from there. 2 is common in both of those. So that will become, in fact, I can just divide by 2. That's even better. Divide by 2. But don't divide by cosine x, although it won't really affect the answer here. Just get into the habit of never dividing by a variable in order to get rid of a factor. So here we're going to divide by 2, so we have 5 cosine cubed x minus 3 cosine x equals 0. Cosine x is common, always take it as a common factor. That gives you 5 cosine squared x minus 3 equals 0. So we have now cosine x equals 0. And we have 5 cosine squared x minus 3 equals 0. Now this one, we can solve it. We can write this as cosine squared x equals 3/5. So cosine x equals plus or minus the square root of 3/5. Therefore x is equal to, so we're going to put inverse cosine. Let's use the positive one, because the angle we can see is between 0 and 90. We got to in radian mode, so shift cosine of the square root of 3/5. And that gives us 0.68471. 0.68471. We should always use radians, not only because it says radians here, but because whenever we use calculus, differentiation, integration, we should always deal with radians when we have trig functions. So this becomes, in radians, should be written to 3 significant figures. So x equals 0.685 radians. This is in radians. So there we have the answer. That's the x coordinate of m. Okay, at m, x is equal to this angle in radians. So there we have the answer to this question. Now, what about cosine x equals 0? when cosine x equals 0, x is equal to pi over 2. Yes, so that gives us the same solution. Cosine x equals 0, inverse, as we know, cosine curve goes like this. At pi over 2, it's equal to 0. So that gives us a minimum again, which is over there. So that's that's what we don't need. We want this place, and that's what this solution gives us, and that's what we're looking for. So that's the value of x at the point M. Okay, so there, that basically concludes 9 part A. 9 part B is about the same equation, but it's to do with the area under the curve, which is to do with integration. And to keep my topics, classified according to topic, I'm going to do that in a separate video. So 9 part B, you will find it, if you want to find it, in the playlist that will appear at the top of the page over here. Other questions dealing with differentiation, you can find in this playlist over here. I'll also put this in the topic of trig identities, okay, because it's related to that also, which you'll find the playlist over here, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.